To solve these two equations, the first thing that you notice is that the equations have fractions. So what you want to do is immediately multiply both sides by the denominators, and that's going to get rid of your fractions. So my only denominators in this equation, I have a v in the denominator and a v in the denominator. They're the same denominators. So I'm going to multiply both sides by just v. Now when I multiply the left side by v, I'm going to have to distribute that through. So v multiplied by v is v squared. But when you multiply this second fraction, this fraction right here by v, this v cancels that v out. And the only thing I have left is plus 11. I'm going to bring down my equal sign. When I multiply the right side by v, it cancels the v in the denominator. So all I have left is the 27. Now we have an equation that looks a lot easier. But before we finish solving, let's remind ourselves that anytime your original equation has a variable in the denominator, checking your answers is not optional. You have to make sure that whatever your answer is doesn't lead to dividing by 0. So what would the only number that would make these original fractions divide by 0? Just simply be 0. If it was x minus 2, I'd plug in 2, but they're just v's. So if when we solve this, we get 0 for an answer, we're gonna have to throw it out. Okay, we could go ahead and get the v squared by itself by subtracting 11 from both sides. So then v squared is equal to 16. Square root both sides, and I end up getting 4. 4 times 4 is 16, but remember, whenever you take the even root of both sides, you're going to get both positive and negative. So square rooting both sides, we get 4 and negative 4. I should check my answers. If I substitute 4 back in the original, you can simplify all the way, but really, again, all I'm worried about is dividing by 0. So if I put a 4 in the denominator here and a 4 in the denominator here, I'm not dividing by 0. Or if I put negative 4 in the denominators, I'm not dividing by 0. So I'm confident these are the right answers. Okay, so now let's take a look at this one here. Oops. If I have denominators w and w, I'm going to multiply both sides by w. On both the left and right side, I'm going to need to distribute. Okay, so let's take w multiplied by w, and that gives me w squared. W multiplied by this fraction here, this w is going to cancel this w in the denominator. So all I have left is minus 6. Okay, then here, if I take w multiplied by 3, I get 3w. Let me go ahead and bring down my equal sign. And then w times this fraction, this w cancels this w, so all I have left is plus 12. Now one of my variables is to the second power, and I do have a w term, so I need to move everything to the same side equal to 0. I prefer to make sure that the number in front of my variable squared is positive to make factoring easier. So I want to move, this is already a positive 1w squared, so I want to move everything to the left to keep that a positive. So I want to subtract 3w and subtract 12. Whatever I do to one side, I do to the other. And this will now equal 0. But if we do this, we are going to have w squared minus 3w, and then negative 6 minus 12 is negative 18. We want to factor, so thinking of two numbers that multiply together to get negative 18 and add up to negative 3. That's going to be negative 6 and positive 3. When two things multiply together to get 0, the only way that happens is if one of those is equal to 0. So I'm going to set each piece equal to 0. So w minus 6 equal to 0 and w plus 3 equals 0. If I add 6 to both sides, I get 6. If I subtract 3 from both sides, I get negative 3. And just a quick reminder, anytime your original equation has a variable in the denominator, checking your answers is not optional. And what we're worried about is these numbers leading to dividing by 0. But if I put 6 up here, my denominators are 6. If I put negative 3, my denominators are negative 3. So I would not be dividing by 0, so I get to keep both of those answers.